Time travel, possible or not? Time travel is a very popular topic both for scientists and science fiction. Imagine if we were able to travel into the past and visit Marilyn Monroe or drop in on Galileo. Traveling at 2 points in time, the idea itself is alluring. We have seen different movies that use time travel, and each have their own theories for it. But the reality is a bit different. Not all the scientists agree on the idea of time travel, and the process itself has complications. But before that, we need to understand, what is time? We all know about the three spatial dimensions that make up space. All physical objects exist in 3 dimensions. They are length, width, and height. There's also a 4th dimension, and that is time. We have to do something to move in the above 3 dimensions. Like if we move in a car in a straight direction, we move along 1 dimension. When we take a turn, we move along the 2nd dimension, and when we move up a cliff, we move along the 2nd direction. But moving through time is always happening. Everything has a length in time as well as space, whether we are at rest or in motion in space. We are constantly moving through time, and this relationship gives birth to the concept of space-time and time dilation. We will come back to that later on. The most complex idea of time travel is the time travel to the past. Generally, many scientists believe that it is not possible because paradoxes are involved in it. The most general idea is traveling in the past through wormholes. Einstein's general relativity permits the idea of wormholes. Wormholes are a tricky concept, but stay with us. We all know that all the 3 dimensions are not entirely perfect. If you look closely enough at anything, they all have holes and wrinkles in them. It's a basic physical principle and even applies to science. For example, if we take a pool table and examine it at a molecular level, it's full of gaps and holes. Nothing is entirely perfect. It's easy to show this with all the 3 dimensions, but it also exists in time. There are tiny crevices and voids in time, down to the smallest of scales, smaller than even atoms. We get to a place called the quantum foam, and this is where wormholes exist. Tiny tunnels or shortcuts through space and time, constantly forming and disappearing. They can link 2 separate places at different times. Unfortunately, these time tunnels are a billionth of a centimeter small, too small for a human to pass. Some scientists think that it might be possible to capture one and enlarge it trillions of times with a lot of energy to make it big enough for a human to pass. You might have seen this concept used in the Avengers Endgame, but wormholes are a tricky concept to wrap your head around, but many think it's not possible in real life. Let's discuss why. One of the main reasons are the paradoxes that might prevent time travel. Let's consider a simple version of it. Let's suppose you're able to travel back in time and meet your grandfather, and just suppose that you didn't like him and you shot him. I'm just asking every one of you to just take a hypothetical situation, not to offend anyone. So in case you shot him, then he would never have met your grandmother, and your dad would have never been born. And if your dad would never have been born, then he would never have been born. Still, you are alive and able to go back in time and meet your grandpa. Well, the loop goes on. This doesn't make sense. This kind of time machine would violate the fundamental laws of the universe. The law of causality, i.e., the causes happen before the effects and never the other way around. And I believe that things can't make them impossible because that could lead the whole universe into chaos. So it's believed that something always prevents the paradox. Something will always prevent us from going back and killing our grandfather. Hope you all got a clear understanding of what we meant to say. In the end, wormholes might not be possible. Those small wormholes might exist, and it may be possible to inflate one, but it won't last long enough for a time machine. So any kind of time travel to the past is not possible, otherwise paradox would occur. It's a disappointment, but it doesn't mean time travel is not possible. We believe that time travel to the future is always possible. This idea of time travel to the future is derived from Einstein's relativity. This is where the concept of time dilation comes in. We already discussed how we move against time. Time and space are interchangeable, or we can say they are 2 sides of a coin. So when we move through space, some of the motion can be thought of as being diverted into motion through time and vice versa. in much the same way as a car traveling northwest diverts some of its northwards motion towards west. Space and time are interrelated, somewhat like X and Y axis as shown in Figure 3. The only difference is that we cannot move only through space. We move through time also. We always move through time. When we are at rest, we move only through time, but when we move through space also, some of our motion through time is diverted towards space, and so the time is less than it should be, or we can say time is dilated. The concept of time dilation is one of the most fascinating ideas in physics. A strange conclusion from Einstein's work is that time moves relative to the observer. An object in motion experiences time dilation, meaning that time moves more slowly when one is moving than when one is at rest. Therefore, a person moving ages more slowly than the one at rest. So we're able to say that moving clocks run slower than those at rest. How? Well, as I have explained above, when we move through space, some of our motion is diverted from time to space, and time moves slowly. For a person moving, time would move normally for him, but when observed from a different inertial frame, which is at rest, it would appear to be moving slowly. This becomes extremely apparent at speeds approaching the speed of light. Imagine a 15-year-old traveling at 99.5% the speed of light for 5 years, from his perspective. When he would get back to Earth, according to NASA, he would be only 20 years old. His twin on Earth, however, would be 65 years old. This is also called twin paradox. So when astronaut Scott Kelly spent nearly a year aboard the International Space Station in 2015-2016, his twin brother Mark Kelly aged a little faster than Scott. To some extent, I am able to say the quicker or faster you go, the slower you age. The reason it is not noticeable in everyday life is that we move with velocity much smaller than the speed of light. The nearer the speed of an object approaches the speed of light, the more warped lengths and time intervals tend to become. We can very easily see the most practical application of this dilation, the GPS system. If you have a global positioning system, GPS receiver in your car, the receiver attempts to find signals from at least 3 satellites to coordinate your position. The GPS sends out timed radio signals that the receiver listens to, triangulating its position based on travel time of signals. The challenge is the atomic clocks on the GPS are moving and would therefore move slower and also move faster due to weaker gravity, because gravity also dilates time. We will discuss this aspect in general relativity. But overall, they move faster than clocks on Earth, creating timing issues. The clocks in our space are ticking faster because the GPS satellites are above Earth and experience weaker gravity. So even though the GPS satellites, which are always moving, they experience a 7 microsecond of slowing every day because of their movement. The result of the weaker gravity causes clocks to tick quicker for about 45 microseconds faster than the ground-based clocks on Earth. So now when we add the two observations together, it leads to the GPS satellite clock ticking faster than ground-based clocks on Earth by about 38 microseconds every day. So engineers do have to make the clocks on a GPS tick slower. So we can assume that traveling at the speed approaching the speed of light would hypothetically enable time travel into the future, as time slows down for the speeding object in order to prevent the cosmic speed restriction of the speed of light. A corollary of all of this is that if it were possible to exceed the speed of light, then we could go back in time. It is shown in the TV series The Flash, although some scientists believe that some as yet undiscovered law of physics may intervene to prevent such paradoxes. Actually, special relativity does not forbid the existence of particles that can travel at speeds faster than the speed of light, and there's a theoretical subatomic particle known as tachyon, which might spend its life traveling faster than the speed of light. However, it's still hypothetical. Time travel into the future is also possible because of gravity. Let's use the two twins again. If one among them sits in a spaceship that goes into orbit into a black hole, the gravity of the black hole causes the time to tick slower, as represented in the movie Interstellar. Cooper and his mates landed on a large watery planet on which gravity is 130% stronger than Earth and is situated near a supermassive black hole having a mass of about 1,000,000 times greater than the Sun, which it orbits at 55% of the speed of light. So that means that Cooper's friends that are on the spaceship experience time faster. An hour on the planet equals 70 years on the spaceship. That's truly amazing. Though the concept of time travel in the future is not much entertained. Time travel to the future is a very likely event. Maybe in the future, we might see it. So what do you think about the concept of time travel? If you have any questions or reviews, be sure to leave them in the comment section below. And don't forget to like, subscribe, and share our video. Thanks.